So again, this is just raw footage here. I'm reading the problem for the first time. The following table gives the average cost to the nearest 100 of a new four-door sedan. So it says, use the information to construct a quadratic regression to represent this model, rounding all constants to 3 decimal places. We're going to round all constants to 2 decimal places. X equals 1 for 1991. That's helpful. So 4 would be 1994, 7, 10, and 13 would be our numbers that we'll input into the calculator. So go ahead and go to Stat. We're going to edit our lists. And again, if we have numbers already in the list, we're going to highlight list 1, hit the clear button, push the enter key, do the same, repeat the same for the list 2, and so we want to clear all of our data. Now we input our new data, 1, 4, 7, 10, and 13, enter, and then we're going to go ahead and type in, oops, one too many zeros there, 12,800. This, what is it again? The average cost of a new four-door sedan. Okay, so let's see, when did I start driving? I started driving in 1981, and now the cost of a four-door sedan has skyrocketed like crazy. 19.2, 24.3, and $30,100. Now, with the data, we're going to calculate our quadratic regression. So stat, calculate, 5 for quadratic regression. Let's go ahead and store it again in y1. So vars, y variables, function mode, y1, enter. Go ahead and calculate it, and then let's write it down. So we have f of x equals 60.32x squared plus 602.22, I'm running out of room for my hand, 0.22x, and then plus 12,123.17. So there's our quadratic regression model, and we want to use this regression model, estimate during which year the average cost would be 37,000. So what we're trying to find here for part B is we're trying to find this number here when the value of the function is 37,000. So we're going to go ahead and type in and go into our y1, and we want to know, well, let's go ahead and look at the data first of all. Let's see what it looks like. Here's our regression function, and we notice that the r squared, I forgot to write that down, but the r squared was 99.9%, something, I thought I saw something like that, 0.999. So 0.999 means that our quadratic regression model almost perfectly meets or represents the data that we were given in the table. So that's a really, really good number. It means that we can be very sure that we can make some really good predictions about what's going to happen in the future. So we want to know, though, what year the value of the four-door sedans is going to hit 37,000. So we're going to go back into our y equals and type in 37,000 because we want the value of the functions to be equal to one another, one value being 37,000. Before we hit graph, let's go into the window and make sure we can actually see 37,000. We have an x max of 14, so that means the year past 1990, and we don't know what year, so let's increase that a little bit. Let's increase that to 30 so we can go all the way to 2020. And then the y min looks okay. The y max, though, we want our range to include our 37,000, so let's go all the way up to 40,000. Just so we have a little bit of space above the 37,000 graph. And then again, let's change xres to 3 so it graphs it faster. So there we have it. Somewhere over here, we'll see our point of intersection. So we second calculate intersection, and we go enter, 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 and enter, enter selects the first and second graphs, and then the third enter is our guess for where the intersection point is. So we see that when x is 15.92, that's when the value of the cars are going to be, average cost of the car is going to be $37,000. So let's write that down though. When f of x equals 37,000, when x has a value of 15.92. Let's interpret what that means. So 15.92, that's the number of years past 1990, and so that would be roughly 2005.92, so almost 2006. Estimate during which year? So in the therefore late in the year 2005, the average cost of a four-door sedan, a new four-door sedan will reach $37,000. Now we don't know that for sure, but that's what we do when we estimate. That's what we mean by estimate. We're going to estimate that year. All right, and I'll do one more video for problem number 4.